Okay, so yesterday we talked about coordinate conversion. Today we're going to be talking about equation conversion. So going from polar equations to rectangular equations. So basically eliminating the r and the theta so we can get it back to x and y. First, let's refresh about the equations that we used yesterday. So we used x equals r cosine theta, y equals r sine theta. We used tangent theta is equal to y over x, and r squared equals x squared plus y squared. Okay, so we used these equations. Now, when we're gonna base the information we're given off of these equations. So on the first one, I'm given just r equals 2. Okay. Well, if I look at this equation, I don't have a theta, so I'm not going to use this one. Same with this one. This doesn't even have an r in it, so I can't use that one. So my best bet would be to use this last one. So if I took that, plugged in 2 for r, I get 2 squared equals x squared plus y squared. Okay, well 2 squared is 4 equals x squared plus y squared. This should look like a formula that we used last week. Okay, this would be a circle. So I could stop here because I eliminated the r and theta. I don't have those anymore in my equation. So this is a rectangular formula. If you would like, you could go ahead and solve for y like you're used to, or you could just leave it in this form. Let's look at another example. This time, if they give me theta is equal to pi over 3. Okay, so if we look, these equations have an r and theta, but I'm only given theta, so I don't want to use those because I don't know anything about r. This one I could use, and this one I don't have an r. So I'm going to use tangent, plug in pi over 3 for theta, equals y over x. Okay, if I go to the unit circle, remember pi over 3 is somewhere about here. The coordinates would be 1/2 root 3 over 2. So if I divided these, y over x, remember your denominators go away, so it'd be root 3 over 1. And I'm going to set it equal to y over x. So from here, I can cross multiply and get root 3x equals to y. And if we look, oh, it's already in y equals, so I can have that. That's my equation. Y equals the root 3 of x. So that would be your rectangular equation. Okay, one more example. Example 3. I'm given r equals secant theta. Okay. If we look back at these equations, doesn't really look like any of these. These for sure, because they don't both have an r and theta. So I need to get maybe it to look like one of these two, because I have an r and theta. So we're going to go back to our trig rules and put things in terms of sine and cosine. So r equals, well, secant is the same thing as 1 over cosine theta. Okay. And if I want to get rid of this fraction, I can go ahead and multiply by cosine theta on both sides, so that gets rid of that. So then I could rewrite this as r cosine theta equal 1. And if we go back up to what we had to begin with, oh look, there's r cosine theta, and that was equal to x. So basically, I just take this is x, because that's what it says at the beginning, equals 1. Eliminated the r, eliminated the theta. There's your rectangular equation. So what you need to do is you need to make sure you use the correct equation, which one has the information that you have the most about, and then go from there. Your assignment for this is page 784, numbers 50 through 56 evens. Please let me know if you have any questions, and good luck.